Today we're going to be doing some math with a physics formula, which is a quadratic. And the one that we're going to look at is projectile motion. This formula is in feet. And we have the height at a given time is equal to negative 16 t squared plus v naught. And v is your velocity, and this little subscript of 0 is at time 0. So this is our initial velocity. Plus h naught, and the little 0 here for the subscript is time 0, so this is our initial height. The negative 16 has to do with the gravitational constant of Earth. In feet, it's negative 32 feet per second squared, and if we were working in meters, it would be negative 9.8 meters per second squared, and then you have to take 1/2 of that gravitational constant for this formula. But you don't need to know that. You're just going to be using negative 16 here. Everything we're going to do is going to be in feet for this set of notes. So here I told you what everything meant. So for example 1, a rocket is launched from atop a 101-foot cliff with initial velocity. So they just gave us our velocity at time 0. And they also gave us 100-foot cliff, that is our initial height. So let's plug those in because that's our first question here. And we're going to substitute those values into the vertical motion formula. Oh, it said let h equal 0, so let's go ahead and let h equal 0 here. So I have negative 16 t squared plus my initial velocity plus my initial height. For part C of this, we're going to use the quadratic formula to find out how long the rocket will take to hit the ground. So I'm looking for my x-intercepts here when I want it to hit the ground. And it hits the ground when your height is equal to 0. I could have asked for the maximum height it reaches, which would be looking for the y-coordinate of the vertex, or I could ask for how long it takes to reach that maximum height. In that case, I would be looking for the x-coordinate of the vertex. This question asks for the x-intercepts, though. So h of t is 0. And that is equal then to the negative 16 t squared plus 116t plus h naught, which we wrote above. And now we're going to use our a, b, and c values and plug them in the quadratic formula. This would not factor, and I couldn't use the square root property on it. A is negative 16, B is 116, and C is 100. And plugging those in, instead of using x, they did use t, so we'll just use t here. So t is equal to negative 116 plus or minus the square root. When you square 116, you get 13,456. Minus 4 times a, which is negative 16, times c, which is 100. And that is all divided by 2 times a. Simplifying the value under the radical, remember that is called the discriminant. You get negative 116 plus or minus the square root of 19,920, and that is all divided by 2 times a, which is negative 32. This is not a perfect square. We're going to plug that in. Remember, you put the numerator in parentheses. We have 2 solutions we need to find. So the first one is negative 116 plus the square root of 19,920. And then you'll divide that by negative 32. And so that is approximately negative 0.8. And that's a negative value that happened before the rocket took off. The rocket would have been on the ground, or maybe a little bit off the ground, so that's why that wouldn't be 0 right there. And then the second one, I have negative 116 minus the square root of 19,920. Make sure your numerator is in parentheses. That is divided by negative 32. And this one is approximately 8.0 seconds. Remember, we're finding time, and this is in seconds. For example 2. You and a friend are hiking in the mountains. You want to climb a ledge that is 20 feet above you. So they just gave us our height. The height, the grappling hook you throw is given by the following function. This would be our initial velocity here. And this is our initial height. What is the maximum height of the grappling hook? So how far can you throw this up above you? So let's look at this. I'm asking for maximum, and this is height. Maximum, remember, is vertex. And height is going to be the y-coordinate. Time would be the x-coordinate. So I want the vertex y-coordinate. To find the vertex y-coordinate, you still have to find the x-coordinate of the vertex. And then you plug in that x-coordinate you find to find the y-coordinate. So the x-coordinate is our t value. So x equals negative b over 2a. That's going to be negative 32. We can write our a, b, and c here. So a was negative 16, b was 32, and c is 5 in this case. So it's over 2 times a. So negative 32 over negative 32 is equal to 1. To find the y-coordinate, you need to plug in x as 1. So, and this is our h of t, our height. And so that's going to be negative 16 times our time, which we just found, which is 1 squared, plus 32 times 1, plus 5. And that gives us 21, and this is in feet. And the next question asks, can you throw it high enough to reach the ledge? And so, yes. The maximum height it can reach is 21 feet above the ledge. Which is more than 20. So more than the ledge of 20 feet. Question 3. A diver stuntman is standing on a cruise ship 40 feet above the ocean. They just gave us our initial height. This is the height at time 0, so that's that little h naught. He free falls. So your initial velocity starts at 0 when you free fall or drop something. So free falls means our initial velocity is equal to 0. If you throw something, it would have initial velocity. But if you drop or free fall, it will have an initial velocity of 0. From the boat, so I even told you here, the initial velocity is 0. Use the formula. So this is our formula we've been using in the last 2 examples, where h is the height above the water, t is the time, v naught is the initial velocity, and h naught is the starting height. How long will it take him to hit the water? Okay, and when I asked for hit the water, they just gave you the height, h of t, is equal to 0. So the height at the ground level or water level is going to be 0. So let's plug in everything we know. So our initial height is 0. That's equal to negative 16 t squared. Our initial velocity was 0, so 0 times t, that goes away. Plus our initial height, which is 40. I need to solve for t here. I don't have a graph. Square root property, I don't have the middle t term this time. So square root property is a great choice for this. I'm going to add 16t squared to both sides. And then divide by 16. And then take the square root to undo a square. You'll get 2 solutions, plus or minus. When you take the square root of that, you have plus or minus, and this is approximately 1.58. However, the negative one does not make sense for the problem, so you'll only keep the positive solution. So it'll be 1.58, and this is time, and this is seconds. For example 4. A hunter on a cliff 144 feet above the ground level shoots at a duck and misses. If the bullet coming out of the barrel has an initial velocity of 128 feet per second from the top of the cliff 144 feet above the ground, what is the maximum height the bullet reaches? When does it reach that height? How long before it hits the ground? There's a lot of information here. First thing that they give us is our initial height here. So that's h sub 0, or h naught. And they give us our initial velocity here. So that's my v naught. So time 0, that's our initial velocity. And again, they gave us the height again. We already knew that. What is the max height the bullet reaches? So maximum height, they're asking for the y-coordinate of the vertex. They're asking when, which is the x-coordinate of the vertex. And when they ask how long before it reaches the ground, well, that's your x-intercepts. So let's look and solve for each piece of this. How long did it take to reach the maximum? So that's the vertex x-coordinate. So to do that, I'll use x equals negative b over 2a. And remember, instead of using x this time, we're using t for time. In fact, let's go ahead and write our equation up here. So h of t is equal to negative 16t squared plus our initial velocity is 128 times t plus our initial height, which is 144. So I just plugged in my height and my initial velocity to the formula. So this is A, B, and C. So the opposite of B is negative 128. And that's over 2 times negative 16, which is negative 32. And that gives us 4. And this is in seconds. For part B, I'm asking the maximum height. So now I want the vertex y-coordinate. And we've used h of t for the y-coordinate. Up here for the x-coordinate, we used t instead of x. And so I just need to plug in the 4 seconds into this equation. So h of t, and this is t equals 4 we're plugging in, is negative 16 times 4 squared plus 128 times 4 plus 144. And that will give you 400, and this is in feet. The last thing is, when does it hit the ground? So we're wanting to know when h of t is equal to 0. So I'm going to plug in 0 here. I don't have a graph, so I'm not going to solve it with a graph. I have a middle term, so I'm not going to use square root property. It does factor. If you don't want to try and have to figure out numbers that are large for factoring, that is okay. You can go ahead and use the quadratic formula. I do notice that these are all divisible by negative 16. So that will be t squared minus 8t minus 9. And I need something that multiplies to negative 9 and adds to negative 8. So that's negative 9 and 1. I'll write that to the side. So you wanted it to multiply to negative 9 and add to negative 8. So my numbers I found were negative 9 and positive 1. What makes this first factor 0 is 9. And the second factor is 0 if t is negative 1. I will have to throw the negative 1 out. And so the hunter's bullet will hit the ground after 9 seconds. This concludes our notes for the day.